Hello learner, welcome to the learning of computer networks and security. Let's continue with the module 3 concepts. Let's see multicast routing problem now. So before moving on to this algorithm, we'll just see what is multicasting. Multicasting is the one where it is totally different from unicasting and broadcasting. So unicasting is what? It is something like one-to-one, right? So one sender and one receiver. What is broadcasting? It is something like one sender and multiple receivers. But what is multicasting? It is something like one sender and multiple receivers, but provided those multiple receivers are nothing but the sender and multiple receivers are nothing but the subset of the nodes in the network. So it is something like I have this network, consider this network, okay? So in this network, what would be unicasting? If I send from this system, this node to the other node, this becomes unicasting, one node to the other node. What is broadcasting? If I send from this particular node to all the nodes, say first node here, second node here, and then third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, all the other nodes, then it becomes broadcasting. But what is multicasting? I said if you send from one node, say suppose I select this as a sender node, from this node to subset of nodes. So which are the subset of nodes? You just see here which are in red color. Node 1, then node 2, and then node 3. These are the three nodes. And which are the routers which are connected to those nodes? That is router 1, router 2, router 3, and finally this router 4. There are 4 routers which are connected to these nodes. So this forms one group of nodes, or you can call them as subset of nodes in the network, and you can now call them as multicast tree. So here multicast tree is nothing but all the members are now part of this multicast tree. So here any one node will be sending to a group of nodes, not all the nodes in the network. It is only for a group of nodes here in the network. So here you can just see only those link which are marked in red color will be used up for sending the packets to this multicast tree or the multicast group. So not all paths are used here, right? Only those paths which are marked in red color. So you can just see here a tree, that is the same thing what I said. Not all paths between the routers used will be something like not all paths between the routers are used up. Next we have shared tree. Same tree used by all group members. You can just see here same tree, that is the shared tree. You can call this as now shared tree. So it is something like the same tree will be used by all the group members. If I'm drawing this as a separate tree, so this is a node and then which is connected to a router, and that is again connected to the next router, and then in turn it is connected to 2 other routers there, right? So 2 other routers, so something like this. So here 1 to 1 and then this link. So you can just call this something like this. Yeah, one more. This router is actually not belonging to our multicast. Okay, so here you can see this way, and here you have one more intermediate router. So here this router is not belonging to our multicast group. This is also not belonging to our multicast group. So which are there in our group? 1, 2, 1, 2, 3, and then 4. There are total 4 routers which are there in our group, and all these will share the same tree here. So we call that as shared tree. So you can just see here, this is an example of shared tree, whatever I was saying. Now we will just see what is source based tree. There's also one more type of tree. that is source based tree. What is it? So you can just see here, source based tree is the one where we have one node can act as a source. In this multicast group we can have one node acting as a source, and then all other nodes here in the multicast group are receivers. So if I select this as a source node, rest other nodes can become the receivers. So this becomes one tree for this particular source node. So you call this as source node tree. Now one more tree I'm going to consider. So that next tree will have, I will have a different source. So this source will be now sending, and all the other nodes will be acting as receivers. So that becomes a different tree. Again the third node now may, if it acts as a source, that becomes a third source based tree. So source based tree it is nothing but we can have different tree structures for different sources. But what about shared tree? It is like same tree structure for all the group members, for all the group multicast group members. Now we have, as I already said, two approaches for building multicast trees. One is source based tree, so wherein we have only one tree structure for different separate tree structures for separate sources, right? So whenever we construct such trees for the particular source, we are going to follow shortest path. So it is something like, if I have a source here as a router, source router, or you can call it as a source node which is connected to a particular router. So when this acts as a source, so you can there will be several other routers also over there which are acting as a receivers. So here whenever you are sending the data to other receivers, you must follow shortest path algorithm. You can be Dijkstra's algorithm through which you can calculate the shortest path, and also you can also follow this reverse path forwarding technique. So what is reverse path forwarding technique? What we had discussed in the previous concept. So it is something like again it is shortest path. So whenever a packet arrives from the source, when the receiver is receiving that receiver should calculate the shortest path. So shortest path back to the source. So if the packet is received from the shortest path, then only that receiver will accept the packet. Otherwise it will not accept the packet. Okay, so reverse path forwarding is that. Ultimately it leads to shortest path. Next we have group shared tree, wherein we have a multicasting group. Multicast group is nothing but the subset of nodes which are belonging to the network. So those subset, only that particular group members will share one particular tree. So that one particular tree is again a spanning tree. So what is spanning tree? Spanning tree is the one wherein in a multicast group members, suppose in the multicast group if there are 7 nodes, or you can say if there are 7 total routers plus nodes, total if there are 7 host plus router, the count if it is equal to 7, then your spanning tree whatever you construct should contain all those multicast group members, but there should not be any cycles in the group. It should be acyclic. Okay, it should be acyclic. But you remember, all the nodes should be there in the group. So you can also follow center based tree. Center based tree is this one. Okay, we have already seen that in the previous class, center based tree. You can just follow that. Let's see this shortest path tree. Let's see how multicasting forwarding tree is constructed. So you can see tree of shortest path routes from source to all receivers. So here you can see the source node is this node, and remaining all the other nodes which are colored red are participating in multicasting. So you can see R1, R3, R6 and then R4 are the 4 routers which are participating in multicasting. Rest all the other nodes like R2, R5 and R7 are non-multicasting group members. Okay, so here whenever the source node is sending any packet, that packet will be sent to all the routers which are part of this multicasting group, which are those R3, R4 and R6. Okay, and as well as R1. So and these red links are the one which are connecting, which are participating, which are used for forwarding this packets in in multicasting tree. Okay, and you can just see here the link 1, then the link 2, and then the link 3, link 4, then link 5, and then link 6 are the only 6 links that we have, which are used for multicasting, or which are used for forwarding packets along multicasting source based tree. And here the shortest path is used to circulate the packets, or to distribute the packets, and the shortest path algorithm used is distrust, like I already said. Okay. I had already told, this reverse path forwarding technique is also used. So what is reverse path forwarding technique we had discussed? So reverse path forwarding is something like there will be a node which will act as a sender now. So here I'll just consider a router as a sending router, and suppose a router sends a packet, forwards a packet to another node. The receiver, upon receiving, should calculate the reverse path, that is the shortest path back to its source. So if the packet is received from the via the shortest path, then only the receiver is supposed to accept it. If suppose the packet is received via some non-shortest path, the path which is not shortest back to the source, then in that case, suppose if this way the packet is received for this receiver, the receiver is not supposed to accept it. Okay, so receiver can accept only the packet via shortest path. So you can call this as reverse path forwarding technique. The same thing is used here in multicasting also. And here you can just see here the small condition. If the multicast datagram is received on incoming link, and that is on shortest path back to its center. So here center, you can call it as, in source based tree, you can call that source as a center. Okay, then what are you supposed to do? If it is if the receiver receives the data through shortest path, then it can accept, and plus after accepting, after receiving the packet, it can just forward the packets over the outgoing links to the other multicast group members. So after receiving, it can just flood those packets, or it can just forward those packets onto all outgoing links, provided those links are part of multicasting. Okay, if it is not, if the received data is not coming along the shortest path, then the receiver has to just ignore that datagram. Okay, just ignore that datagram. You can just see an example for reverse path forwarding. So here R1, if I call it as a router, here S is acting as a source. You can call this router as a center router, and then all the other routers like R4, which are in red, R6, and then R3 are the routers which are part of multicast group. And there are some links, 1 2 3 4 5 6, there are 6 red links which are part of multicasting, right? So here in reverse path forwarding, what is going to happen? Suppose first the source node sends a packet to R1 will calculate the shortest path back to the source. Definitely it should accept the packet because it is directly connected to the source. And then R1 can flood the packet to R2, I mean it can flood the packet to R3 as well as to R4, right? So here R3, what it is doing, R3 actually will not directly get the R1, it is getting via R2. R2 is not the multicasting group member, but there is no direct link, right? So that is why this is shown this way. Via intermediate router, R3 is getting the incoming packet. Now upon receiving, R3 will calculate the shortest path back to its source. Whether it is getting the packet through the shortest path back to the source, definitely yes. If that is so, R3 will accept, and R3 will again flood the packet. Okay, yeah, but here no outgoing router to any multicast group member. R4, once again, when it receives, it calculates the shortest path back to the source. So definitely it is in shortest path, it will accept, and then R4 again will flood the packet to you can say here R5, you can just see here. Okay, so you can just see here like in the previous example what we had, let's continue that. We had R1 sending the packet to R4, yeah, then from R4 onwards you can just send the packet to R6, right? R4 will actually flood the packet to the other group members like R6, but here you can see here all the other intermediate routers, what about them? R2, R5 and R7 are intermediate routers, right? Don't you think the packets are received here even at the non-multicasting group members? It will also receive. Why? Because there is no direct link between R1 and R3. So R1, if at all it has to send the packet, first it should send to R2 and then to R3. Similarly here R4 also is using R5 to send the packet to R7, to R6, right? But R7 also might receive the packet. So here there are R2, R5, R7 which are also receiving the packet, but since these three routers are not the part of multicasting, once it receives the packet, it has to notify back to the sender. So for R5, who is the sender? R4 is the sender. Similarly for R7, who is the sender? Maybe it will get a packet from R6 or it may get a packet from R4. So R5 is the sender, right? So R5, next again here R2 also will receive a packet from R3. So R2 back to R1, again it will send a message called pruning message. So what is the meaning of pruning message? Here non-multicasting group members like R2, R5 and R7, they will, upon receiving the packet, if since it doesn't want to participate in multicasting, it will simply send a prune message back to the sender. It is something like upstream by router with no downstream group members. It is something like they are sending, they upstreaming the data, that is they are sending the data, the message, prune message, saying that we don't want to be a part of multicasting. That message will be sent up to the sender. So here R4 or maybe it is for R1, it is sent back, and also here R7 will send it to R6, so that here that pruning is done. Pruning means removing, so that link will be removed from the multicast group, okay, or multicast tree. So it is something like that is how non-multicasting group members will keep themselves away from the multicasting tree. Okay, so pruning is happening over there. Next we can see this about shared tree. So as the shared tree we have, it is something like a single tree for all the nodes. That single tree is a multicasting tree what we have, and it is not source based. It is not like separate tree for separate source node. This is something like a single group of multicasting. That entire group acts, or entire tree acts as a shared tree, that is shared for all the group members, right? And remember here minimum cost tree, it is actually the minimum cost tree that is constructed, or the spanning tree that is constructed, where the tree doesn't have any cycles, and also there will be a minimum spanning tree constructed, provided all the cost inside this tree, within the tree, will be least cost. So you can call it as minimum spanning tree that is constructed. Okay. Next, you can also see the center based trees. Center based trees, whatever is constructed, it is something like one node. You can call that node as a source node also, or else simply any node in the multicasting group members. Other than source node is also fine. Other than the source node, any node here can act as a center of the tree. So what is that center? That center is chosen in such a way that that center is now responsible for receiving all prune messages from other non-multicasting group members. So whenever the routers like non-multicasting group members, there are R2, R7 and all, when they send upstream the prune message, that prune message who is supposed to receive? The center node is supposed to receive. Okay, so that center node, once it receives the prune message, then what it can do? It can just keep those non-multicasting group members away from the group. Similarly, that center has one more responsibility. So any group members, any routers, if it wants to participate in multicasting, first those nodes should send or those routers should send join message to this center node. So once the join message is sent to center node is the one which will allow those routers to join the multicast grouping. So here multicast group tree, the join message is sent first. You can just see here join message is sent, and who is actually sending this unicast join message? It is the edge router. So what is the meaning of edge router? So edge router are those which are participating in multicasting. So those edge routers, you call them as edge router, and then they will send the join message, and for whom it is sent to the center router. Okay, so here join message is processed. So here you can see the join message can be this join message can be sent via the non-multicasting group member also. Why? Because see, the center node is may not be directly connected to this edge router and who wants to participate in multicasting. So that might be connected via some non-multicasting group member as well. So join message may have to pass through non-multicasting group member also. Okay, so intermediate routers, and finally it has to be forwarded to the center. Okay, so you can see the join message either hits the existing tree branch for the center or arrives at the center. So it is something like finally that arrives at the center, join message. So that path whatever that join message has taken, that becomes a new branch of the tree for this router. So it is something like, if I have a tree, this acts as a, this acts as a source, sorry, this acts as a center. So here you can see one router which is not a multicasting group member, but here there is one router which acts as a, which now wants to join this multicasting, so this router will send the message first to this non-multicasting group member. Via that it will send to center node, right? So now this non-multicasting group member actually, I mean, has helped in forwarding, right? So this path whatever this router, now one who wants to join, has used, that path actually becomes the new branch for this tree. Okay, multicasting tree. So this is actually about center based trees. You can just see an example for center based tree. So here one node, any one node among this multicasting group members, say here R6 is chosen as a center. So once this is chosen as a center, now a multicasting tree should be constructed. So any router one who wants to join this multicasting tree can send first the join message. So you can just see who is sending the join message. R3 is first sending the join message. Next R4 is sending the join message via R5. You can see R5 is intermediate router that is not participating, but still it is just forwarding that packet join message to R6. R1 also again is trying to join through R4, and R4 will send to R5. Finally it will reach R6. So there should be a link that is created via R1, R4, and finally R6. Okay, this is how the multicasting tree is constructed. And now these R5, R7, R2, if at all they receive the packet, they will send a prune message there in order to keep themselves away from the multicast grouping. Okay. Next we have internet multicast routing. So what is this internet multicasting routing? We have distant vector multicast routing protocol, DVRMP we call, and this is something like a protocol that is used for multicasting. Okay, until now we have not seen any protocol used for this. That is now DVRMP, which is used for multicasting here. And this, as a part of this protocol, we have two things happening. So one is flooding and one more is pruning. So what is this flooding? Flooding is something like you send the packet, see, it's something like a source which will send the packet to all the other multicast group members. So that is called as flooding. And pruning is other non-multicasting group members will, if they want to keep themselves away, they have to send back the prune messages. So it is something like that, prune message. So flood and prune are the two things happening under this, within this distant vector multicast routing protocol. And you can see here reverse path forwarding technique is also followed when the packets are flooded. So what is that? Every node, after receiving the packet, it has to calculate the reverse path, shortest path. It should be through the shortest path back to the sender. It has to receive. Only after it receives through the shortest path, so that router can flood the packets to the other routers. Okay, so and then source based tree is constructed here in DVRMP. So what is source based? One node acts as a source, and if the other node acts as a source, a different tree is followed, a different tree structure is constructed. Okay, so reverse path forwarding technique we have used here, source based tree is constructed, and flooding and pruning technique is also used as a part of DVRMP. Okay, yes, so this is all we have discussed about the DVRMP. And you can just see here It is something like in DVRMP something is happening. So what is that? In DVRMP it always forgets the branches that are pruned. What is the meaning of that? See here, see if this is a first router what we have, and this is a part of multicast, say, and this is a second router which is not a part of multicast. Again we have the third router which is a part of multicast. Okay, this is not a part of multicast. So now when this is not a part of multicast, in the previous stage, whenever the join message, see 3 has sent a join message to this source or center there, and in that case this will accept it. Whereas there is one more multicast group member, say 4, this also wants to join, so it will send the join message via R2 and finally it will reach R1, right? So 4 and 3 has joined the multicast grouping, whereas 2 has not joined, but 2 will have to send pruning message to 1. So next instant of time, what is going to happen? Our DVRMP forgets this prune message and forgets about this router 2. What is that forgetting thing? It will consider this router 2 also as a part of multicast grouping. It will not remember that this 2 had it had pruned itself. So that concept this router 1 will forget. So for every minute this thing is happening. So what should happen there? Every now and then this non multicasting group member should send the prune messages back to the source, okay, or back to the center. So this pruning message should be sent for every or periodically, you can say. Okay, why? Because the router quickly forgets the things there. Okay, yes.